Okay, so I'm just going to give you a few tips to work with here just so that you have some information about Excel. For one thing, when you are completing these problems, the only formulas you need are actually already here. So we've got the NORM.DIST. And by the way, when you're working with these formulas, if you need any help, once you have them typed in here, once you click in here so that you're editing the formula either in the cell or in the editing bar here, then you can click FX and get your dialog box that gives you a little bit more information about the variables that you're inserting. So you notice here that you have a place to put in the X value or the Z value. In the case of the first few problems, you're using the standard normal distribution, which gives a which uses a mean of 0 and a standard deviation of 1. By the way, you're always going to leave this as true because you always want cumulative for these problems. So we rarely use false. We rarely use the distribution without the cumulative area. And then of course your X value or your Z value. Now if you have 0 and 1 here, this X value is automatically the Z. If you have some other mean and standard deviation here, like for example in these problems down here, problem 4, 5, 6, and 7 use a different mean and standard deviation. So those are normal distribution, but they are not standard normal. So for the first few, 1, 2, and particularly 1 and 2, we're using standard normal. So now you've got that information. Now, for one thing, let me switch to my webcam for a minute and show you a couple things about calculating for less than versus greater than or between. So let's go here to the webcam. So I'm just going to show you a couple things here. I'm just going to draw some sort of crude normal distributions, and we'll do so really the examples that you have are examples of calculating. Let's say I'm going to use 1.5 here as my Z score or my X value, and what the examples you have are probability that Z is less than or equal to some cutoff value, and so that indicates the area or the probability to the left here. And so when we calculate that, we're just going to use plain, so we'll put equals in front and then norm.dist, and then we put in our arguments and we'll get that. Now if we're calculating to the right, let's put 1.5 in here, we'll calculate to the right. So this is probability that Z is greater than or equal to 1.5. Then we'll end up using a complements rule. So the total area under the curve is 1, and if we subtract the area to the left of 1.5, then we automatically get what's left, which is the area to the right. So 1 minus norm.dist, and then put in your arguments. Now if you want the area between, let's say negative 2 and 1.5, so that's the probability that Z is between negative 2 and 1.5. Then we're going to do a subtraction. We need to do the norm.dist for the upper value minus, that's a minus there, norm.dist for the lower value. So upper minus lower, and we get the area between. Now it's not just 1.5 minus the negative 2, it's the normal area. So essentially what we're doing is taking the area to the left of the upper, and then we're taking the area, essentially we're going to subtract off the area to the left of the lower. So it's the area to the left of the upper and then subtract off this lower tail, and you're left with the area in between. And so that would be the general subtraction rules for these other calculations. Let me go back here. And then you've of course got, you click this FX, then you get your guidance here. Now for this one down here, problem number 3, it's just the plain Z score. Whoops, hit escape if you click on something that you don't want. So escape gets me out of there. So down here we're just going to use the plain Z score. definition. So the z-score is calculated by doing x minus mu and then dividing by sigma. So I'm going to put an equal first, and then I put in parentheses, my numerator has to be in parentheses, the x value of 39 minus the mean value, which is 30. Close your parentheses around the numerator and then divide by the standard deviation of 5. Big thing about this, when you're calculating in Excel, everything has to be written in line. You can't write your fractions vertically, numerator over denominator, which is why the parentheses around the numerator are necessary. And also make sure you put that equal first to indicate, that you have a formula. So what we're going to do is, I just deleted it, so we'll do 39 minus 30, and then divided by 5, and then when you hit enter, of course, that should calculate. So now we have, now down here, of course, you're going to be working with the area between. And so notice here I've got the norm.dist, norm.dist. I'm just subtracting two different ones, but I'm putting in the mean and the standard deviation that are given in this problem. So the mean of 20, standard deviation of 4. Again, the mean of 20, standard deviation of 4. Then I have the upper value, which is 27. The lower x value is 20. So that's what you're going to be doing there. And then the rest of these, remember, area under the curve and probability are the same. So what you're doing, for example, in problem 5, the area to the right, to the left, is pretty much the same as what you're doing in problem 7, which is probability. Greater than would be like to the right, less than is to the left. And then, of course, problem 6 and problem 4 are essentially equivalent. Just one of them is stated as area, one is stated as probability. So try that out and see if you can figure out this assignment, and email me if you need more help.